Hello again. It's time to get familiar with some of the widely used speech-to-text methodologies. In this lesson, we'll talk about the famous speech recognition library. Well, it's not exactly world famous unless you're a speech and sound tech nerd, but guess what? Now you are, so wear it with pride. The speech recognition library is a powerful and easy-to-use Python tool for converting spoken language into written text. It supports various speech recognition engines and APIs, including Google Web Speech API, Microsoft Bing Voice Recognition, and more. With its simple interface, speech recognition makes it accessible for users to integrate speech-to-text functionality into their projects, whether for voice command applications, transcription services, or interactive voice-driven programs. So, what are we waiting for? Let's learn how to use it. First, we must utilize the Recognizer class, a vital component of the speech recognition library. This class provides various methods and functions for recognizing speech from different sources, such as a microphone or an audio file, and supports multiple speech-to-text APIs. To initialize the recognizer, create an instance of the said class using the speech recognition library. Let's store it in a new variable, naming it intuitively to reflect its purpose. This way, we can easily reference the recognizer throughout our code. Great! We now have our first speech-to-text tool ready to use. So, let's do it. Before transcribing our audio file, I'll store its path in a variable called filePath for later convenience. This makes the code more flexible and easier to maintain. In our case, we don't need to specify the file's absolute path, only its name, because we placed it in the same directory as the notebook. Storing the file path in a variable is always good practice because, first, it keeps the code clean and organized. Second, it makes it easier to update the path if the file location changes. And third, it improves code readability and maintainability. Good to know. Let's now use the recognizer to create a function that takes a file path, processes the audio, and returns the transcribed text. In a new cell, I'll start by typing def to define our function and intuitively name it transcribe_audio. I'll set file path as a required parameter. This way, the function expects a path to the audio file. All right. Now, we need to open the audio file in the function's body. As you can imagine, opening a file uses some of the computer's resources. Therefore, forgetting to close the file upon use can lead to severe issues such as memory leaks. To avoid this, best practice recommends using Python's with statement. The with statement automatically closes the file after use, preventing resource issues without us needing to remember to close it. This is another critical best practice to remember when handling audio or other media files. Great! After with, I'll use the audio file class from the speech recognition library. Audio file will take the path to the audio file and prepare it for further processing. I'll end this line by typing as source, assigning the opened audio file to the variable source. Good. In the next line, I'll create a variable called audio data. Following an equal sign, I'll reference the instance of the recognizer class and use it to invoke a method called record. It captures audio data from a specified source and passes it as an argument. The record method listens to the audio from the source and takes the sound data available in the audio file. Then it converts the audio into a format that can be processed by the speech recognition library, storing a numerical representation of the waveform. This is what we'll keep in the audio data variable. In the next line, I'll send the captured data from the audio data variable to the Google Speech Recognition API using the Recognize Google method. The API is expected to process the audio data and return the transcribed text in a variable called text. Great. Next, print the text to see if it all will work as expected. We'll also return the transcribed text from the transcribe audio function. allowing us to use it elsewhere in the code. Finally, I'll add a line for calling the function with the relevant file path using the appropriate variable. Let's execute this cell and wait for the output to appear. There it is, our first speech-to-text transcription. At first sight, it looks pretty good, doesn't it? Although this is not the correct way of writing my name, the other part of the text seems more or less accurate. Let's break down what happens after we've executed our code. Once recorded and stored under audio data, the sound data represents a digital signal capturing the amplitude variations of the sound wave over time. When we pass this audio data to the Google Web Speech API via the Recognize Google method, several vital steps happen on their servers. The API first transforms the waveform into a spectrogram, a visual representation of the sound frequency's components over time. You might recall from earlier lessons that the short-time Fourier transform is often used to break the time domain signal or waveform into a frequency domain representation or spectrogram. Next, deep neural networks such as CNNs are employed as part of the acoustic modeling mechanism to recognize spectrogram patterns corresponding to specific phonemes. Once the phonemes are recognized, the system uses language modeling to determine how they come together to form meaningful words and sentences. Deep neural networks such as RNNs and transformers predict words and phrases based on the recognized phonemes and context. Okay, after Google servers process the audio, they convert the spoken words into text and send it back to our application. The Recognize Google method receives and assigns it to the variable with the appropriate name. Let's summarize. The speech recognition library is an easy-to-use interface that sends audio data to different speech recognition services, like Google's Web Speech API. It doesn't contain or run speech recognition models. It simply helps you interact with external services like Google's API. The API is where the heavy lifting happens. Once the audio is sent through the Recognize Google function, Google servers process the data using their acoustic and language models. These models convert the audio into text using machine learning algorithms such as deep neural networks or transformers. So it's all clear. Let's now look at the transcription we've just made. I can definitely notice a few shortcomings. Firstly, there are no punctuation marks within the text. Secondly, the words term and in seem out of context and may not be correct. This indicates that the transcription is probably not perfect. But to properly evaluate the result, we need to assess the transcription's accuracy and identify any errors or misinterpretations using proper tools. We'll do this with the help of two metrics: word error rates and character error rate. We'll talk more about these in the next lesson. See you there.